Sure. Good morning, everyone, and good day wherever else you are. I'm Raj Devan, a professor at the iSchool. I moved to Syracuse a couple of years ago, but I've been involved with data science, business analytics, and data visualization from the get-go, more than 10 years. And I'm really excited to be part of the iSchool team. And I'll be teaching a course on data visualization this spring. That's use some of the things I'm going to talk about today. So data science has really transformed the way we use data. Can you advance the slide for me, please? Oh, I see. Got it. And I'm going to do that through some examples. And these examples use different aspects of data science, and they come from a variety of different disciplines. They come from for-profit, not-for-profit, and other areas. And my purpose really is to give you a sense of how powerful these techniques are and how widely they're applicable and what great demand it creates for people who have the skills to do these things. So my first example really makes a very important point. And then one of the biggest changes that has come from data science is that it has transformed the way we and a layperson interacts with data. You might say that data science has transformed the user interface to data. That's the biggest impact. And you see the effect of that everywhere, especially in mass communication. So for example, if you were to buy a copy of today's Wall Street Journal, the print copy, on the very front, it's called the top of the main page, there isn't a big headline. What you have actually is a dashboard composed of 8 different figures giving a sense into how the US economy is doing today. And even better, if you go to the website and look at the same story, all of those graphs are live. So if you move your cursor around, you can actually see the data behind or the number behind the chart. And 10 years ago, this wasn't there at all. And all of this change in the way, for example, newspapers tell us stories has come about because of data science. And this ability to take data and turn them into stories have really wide applicability. Just imagine in a business setting, where you have a large amount of data and you tell a story to a customer or to your boss or to someone else, then how would you do it? These techniques apply, same techniques. So the techniques that Wall Street Journal, New York Times, Washington Post use to communicate with the readers, you can use to communicate with others facts that are derived from data. So here's an example from Wall Street Journal. We recently had Hurricane Ian that tore through Western Florida. And that day, they had, a couple of days later, they had this chart on the Wall Street Journal showing how power outage gradually spread through large parts of Florida. And on the top, it has a chart showing the number. And on the bottom, there's a map showing where that is happening, right? So this is an example of a very simple dashboard. It includes 2 data elements. It includes a map that's live, and then a chart on top. And together, they're telling a story of how Ian impacted the people living in that part of the world on the couple of days when Ian came through, right? Now, I could have had the same thing in a long text article describing it, but I don't need that because this graph tells the whole story, right? That's the power of data visualization. Now, it turns out these newspapers, Wall Street Journal, New York Times, and Washington Post, have hundreds of people who are specialists in data visualization. And if you want to learn how to make a good data visualization, the best thing is look at what they're doing and try to emulate it. And in fact, they make it very easy. Each of them have a Twitter. You can follow them on Twitter. And that's the one at WSJ Graphics, the same NY Time Graphics, Washington Post Graphics. And you can just follow all the, instead of looking through a newspaper, you can just go to the Twitter stream. And every time they have a nice data visualization, it'll show up on the Twitter stream. So you can follow them. And then once you have that, and sometimes you can download the data as public, and you can try to make the same graph yourself and see if you can do that. There's a really wonderful way to learn how to do data visualization. And here's a similar example from New York Times. It was talking about how climate change is affecting the monsoon in India. You probably have a fair number of people from India on Zoom. And it shows on a graph how this last monsoon has been in India. And as you know, that most countries in tropics depend a lot on monsoon rainfall for agriculture and things like that. And the pattern of that is changing. In this story, we wanted to talk about that. And this diagram shows what happened this past year. And once again, you can see, you can follow them on Twitter, and you can get all of these stories directly, and you can see what they're doing with data visualization. In fact, looking at public sources and data visualization is a wonderful way to learn data visualization, as I said before. And one of the really great sources is a website called public.tableau.com. Tableau is a very popular software that people use for making such visualizations. And on public.tableau.com, they have the visualizations, and you can often also just download the data as well. So then you can download that into your computer, and you can then try to make a similar graph yourself. And that process is a learning process where you try to figure out how to do different aspects. And as you get better and better at it, you really become an expert in data visualization. And I want to highlight that. A couple of examples here. This first one is showing data on sales. And the first thing I want you to note in such a diagram is this dashboard is what it's called, is that it includes a variety of charts for one purpose. They're trying to explain how the sales are going in that company right now. And they're showing a variety of charts explaining that. And that's the purpose of the dashboard, to tell a story. And here's one more example. And this is also from Tableau. And here, what this is showing is it's describing how the customer call-in support line is working. And so they have data on how many calls were received, how many chats, how many emails, and how many of these resulted in escalations where someone had to follow back on their conversation. And if we look at this diagram, you see a variety of different charts are used. The one on the top is called a spark line. Then you have a bar chart, and then you have a different kind of a bar chart below. And the important thing is that as you just look at this, you get a quick sense of how things are going in customer support in this company. And if you are a manager in this company and you come in the morning and you can then take a look at the dashboard like this, you can see how things are going. Are products having problems? Are the support people doing a good job? It really gives you a really good sense of how things are moving. And this is also from public.tableau.com. And again, if you go there, you can download this diagram, you can download the workbook, you can download data, and you can see how things are done and learn and really become an expert in data visualization. So the point that I'm making with these examples is that these advanced techniques that rely on being able to combine data from a variety of sources and then use analytics to analyze and to create statistics, and then to visualize them, all of these techniques have really become available to us in a very simple way to use in the last 10 years or so. And these have really transformed the way we interact with data. So now I want to turn to another major aspect of data science, and that is predictive analytics. And I'm going to look at two examples, one from a for-profit and one from not-for-profit, to give you a sense of how powerful these techniques are. There's a very old problem in marketing. It's called marketing attribution. And what that means is when a company is marketing a product, they might have a billboard, they might have magazine advertisements, they might have TV advertisements, and increasingly today, digital advertising. The problem is they don't know which of those is working. Now, digital is a little different, but for traditional marketing, it's very hard to figure out exactly which advertisement is working and which is not. Is it reaching the target customers? Is it raising the right brand awareness? Are they acting on the messages that you're showing them in the advertising? And here's a quote from David Ogilvy. Some of you might know there's a worldwide global marketing company called Ogilvy and Mather. And David Ogilvy was one of the founders of that company. It's a global company all around the world. And he wrote this book really well regarded in marketing, Confessions of an Advertising Man. And in this book, he says, half the money I spend on advertising is wasted. The trouble is, I don't know which half. And what he's saying is, he knows that not all advertising works. Maybe because they don't have the right message, maybe because they don't go to the right target audience, whatever the reason might be, but they don't know why exactly which of those messages is not working, which of them is not well targeted, which of them is not well made, right? And this is a really old issue that's always been there in marketing. And today, we have the ability to crack the nut a bit. And that is called attribution analysis. Now, for digital channels, where you know who sees what, the mystery has largely been solved. But even today, not all advertising is digital, right? You still have billboard ads, you still have magazine ads, you still have commercials on TV, right? Which are really very big. And the question is, which of those is working, which is not? And what really helps solve this problem are two things. One is the ability to combine a large variety of data sources, okay? So for example, if you are interested in knowing which billboards on the roadside are working, you might get data from the State Department of Transportation on the traffic going along that road. And even more, if you knew where your potential customers were and where they were going to work, people traveling from, let's say, a suburb to a central business district, you can then get the traffic flow times and you can see where you had those ads and make some prediction probabilistically on who would have seen those ads, for example, right? Now, that prediction depends on what you did, what ads, what billboards you had, but also data from a public source. In this case, Department of Transportation, showing you traffic on different streets and different roads, right? And that is a very powerful technique, being able to combine diverse data sources that are in different formats, stored in the cloud, stored in different systems, accessible through online API, and to bring all of them, some of them in real time, into a common system, and then come up with actionable intelligence from that. This is an example of that. And that's a really common technique, by the way, that really makes data science very, very powerful. The ability to reach out and include large, diverse data sets in actionable intelligence. Very, very powerful. And here's an example of cracking a really old problem that's been there forever in marketing. And today, many, many companies can figure out, even from a billboard ad, which one, within a day or two, which one is working and which one is not working. They can then change them. And increasingly today, as billboards become digital, they can do it much more quickly. So the whole life cycle, time cycle of these things is now driven by decision-making based on data like this. It's fascinating, really fascinating. Next example of doing something very similar, and what I mean here, taking data from a variety of sources to come up with actionable intelligence, is this example of FoodLink. So FoodLink is an organization that collects surplus food from restaurants, grocery stores, farmers, and then gives them at an almost zero price or very low price, pardon me, to people who don't have enough food. Even in a country like ours, that's developed, with high per capita income, there's surprising amount of food poverty in the country, even in suburbs that seem to be wealthy. And this is the problem that companies like FoodLink, which is a not-for-profit in Rochester area, are trying to solve. And the way they did this initially was they had a warehouse. They got the cheap warehouse in the industrial area. They had these vans, trucks that would go collect the surplus food. They would bring them into the warehouse, and then they would invite people who needed food to come and collect what they wanted, right? What they realized was that the people who have food poverty also don't have transportation, very likely, right? So what they did was, instead of having them come to the warehouse industrial section, they got these vans, they'll put food in them, and like a mobile library, they would go to the neighborhoods, open the doors, and offer the food to people. And at the point where we got involved with them, they've been doing this for a couple of years, And this is what their sales look like. Pardon me. So each dot is a sale at a location, and the size of the dot is how much they sold. Okay. Now they had done this on an ad hoc basis. There really was no science to where they were going, but they knew where people were and so on, mostly based on their experience. And they wanted to make this more rational, more data-driven. And that's where our students came in. And what they did was they looked at their sales data and then added to it many, many more diverse sources of data to it. I've listed some of them there. For example, which elementary schools have high proportion of children getting free lunches, right? Directly relevant, right? That's the neighborhood you want to be in, for example. And then they made a predictive model on where there was food poverty. And this kind of an ugly chart describes it. The green are the areas where there's food poverty in this area. Now, what really surprised FoodLink was the following. Some of those green dots were in what they thought were wealthy suburbs. They weren't even going there, right? It really opened their eyes. And this brings up another really important point of data science. If you do data science well, and you really get into the data, you will get insights that are aha for people who are even experienced in that field. And that is the other thing that really makes data science so powerful, is that it brings to fore things that are latent in the data. And so predictive analytics is not just about finding things about the future, it's also finding things that are hidden. And in this case, it was in the data, but they didn't know it, right? And they found something new. The important principle here that I want to really stress to you is the success of this project hinged on two things. One was the ability to collect data from diverse sources and connect them. That required a lot of programming and scripting to make it work. The second thing that really made it powerful is that the team could communicate this to FoodLink in a very graphic way using data visualization. Those two things are what made this project successful. And that's a really common thing in many data science projects. The next example that Professor Saltz talked about is autonomous driving. I want to see if I can run this video, if I may. So this is a video produced by NVIDIA, which is a very big producer of hardware and software for autonomous driving. And the person who's speaking is the CEO of NVIDIA. I don't think I can get the audio. Zach, think I can get the audio into the room? Well, let me just run this and move forward. I think the video is enough. I'll speak over it. So what's going to happen here is, we often talk about machine learning, how a machine learns how to do something. Now, when you buy a car with autonomous driving today, the model's already built in. So Tesla has already done the work to figure out how to make it happen. And all of that intelligence is already in the computer in the car, right? So the model building is done. There's very little model building that happens after you buy the car. The little that happens is it might learn your driving habits, for example. That may be it, right? Now, the question is, what happens before you buy the car when Tesla engineers, or in this case, NVIDIA engineers, are working on the model to make it learn? And the other advantage of seeing this visually, it really shows you how machine learning progresses, okay? So what's going to happen in this is they're going to have a car with very rudimentary model built into the car. They're going to take it into a parking lot and just have it drive around cones, just like you would when you're learning driving, okay? And you'll see how badly it does. Then after about 2 or 3 months of doing that, driving around, collecting the data and learning in the machine, you'll see how much better it gets. This will give you a sense of how powerful and how machine learning actually works. So now it's not learned yet, it's very rudimentary. And look at how badly it's doing. So, but all of those interactions, the machine is learning. Now, after 3,000 miles, and this is in New Jersey, by the way, that's a model that has gone through some learning. On a 2-lane road, merging. On a 1-lane road with no marking. Dirt road with undefined boundaries. Now, the learning that you saw there, what's really happening is that you have a hardware software system in the car is getting all the inputs from the different sensors and what the driver is doing to correct it and learning from that. That data is supervising the learning in the car. And then after it's gone through this for a few months and they've debugged it and so on, they can then take this and make it a product and sell it in a car. That's how autonomous driving works. Now, what you're seeing there, this ability to learn something complex, like driving on an unmarked road, you can use this kind of learning for any other decision making. And that's the idea behind deep learning. Take this ability essentially to create essentially a robot, as it were, that has learned decision making from complex sources of data and to put that into play. And this technique is very, very powerful and being used really widely. You may not even realize by, for example, autonomous cars, of course, are a common example, but really much more widely than that. So one example I don't have there is machine translation by Facebook. So Facebook has over 3 billion, a shocking number of users. And many of them, they don't just live in English-speaking parts of the world. They live and they speak other languages like Burmese and Japanese and Czech and so on. And Facebook wants those posts to be accessible globally. And so what they did was they built a machine learning system that can translate between 200 languages back and forth. And they serve billions of translations every day. And that whole system is powered by deep learning. And they essentially created a system that learned how to do it. And so they again had 2 phases. First, they had AI research people build the model. And then they took the built model and built a production system in a separate data center, whose purpose was just to do the translation itself. And that is often how deep learning models are put into practice. It goes through 2 phases: building, testing, validating, and then production, where you actually use it to make decisions. And the other really big example of use of deep learning is really, as Salt said, is to really understand what humans are writing or saying or speaking or expressing. And one of the really common uses of this in marketing is just say, is it good or bad, right? It's a very common question. Does someone write something and has a comment about your product? And the first simple question is it good or bad? Then you might say, okay, what is it good about and what is it bad about? These are exactly things that you will learn at the iSchool on how to do. And this is a very common topic called sentiment analysis and then topic analysis, where you can look at what people are writing, figure out what they're writing about, and what they're saying about it. Let me take a real world example. It's very common, for example, to do like a survey, a user survey, where in the first part, you might have numeric ratings, right? And then in the end, you might have some open-ended questions where you have the customer or the user write some comments that they have experienced about your product, good or bad. Now, it's really easy to analyze the numbers, talk about, you can make a chart showing the average rating, median rating, dispersion of rating. So numerical things are easy to work with, right? When it comes to the written part, what do you do with that? Let's say you have 100,000 written comments, each of them varying from just a couple of words all the way to a long paragraph. What are you going to show to your manager, right? Now, one thing you could do is have someone read them all and say which of them are good, what are bad, what are they talking about. But on an ongoing basis, if you're doing this on a website, collecting data on a regular basis, you can't do that, right? And so that's where machine learning comes in. You can build a system that, that has learned, you build a model that learns how to classify messages based on what they're expressing and about what. And then in real time, as people fill in messages or in social media, you can then process them on every day, show a dashboard to the management or the people who are interested on what people are saying about the product today. And this is very, very powerful. You know, it used to be when managers or companies make product changes, they would find out how well or how badly their product design was doing after the sales numbers rolled in, which could be months after the product design was done, right? Today, you can find reactions to your product or your decisions instantaneously on a daily basis from social media. And then you can use that as a direct feedback and take corrective or improving actions on a much tighter cycle. And that is what all the big brands are doing today. And that is why there's a huge demand for data science in marketing, enormous demand. And what these companies basically do, they've come much closer to the customer by using data science, essentially. So I've given you a sense of the kinds of things and the power that data science has, the ability to, the new interface that we have to data, the data visualization part, the ability to bring data from diverse sources and turn them to actionable things. The example from that we had from FoodLink and from marketing attribution, and then how powerful the learning techniques are. The examples we had from autonomous driving, and then from sentiment analysis. Now, what I would talk a little bit about is what's needed on your part to succeed at this new profession. And so the first thing, which I think is really, really important, is communication. Now, communication is not so much accent or how good your English necessarily is, but how well you express what you're trying to say, right? In other words, good communication is purposeful, is that you have something you want to convey and you convey it, right? Whether you convey it orally, whether you convey it using data and visualization, which is where we're going, of course. But the big thing about communication is that is what makes data science actionable. You know, you can build all the best models you want, do all the analysis, but you can't convince anyone in the organization to adopt your model. It's worthless, right? So at some point, you have to go beyond people who know what analytics is. You have to go beyond where people know what data science is and tell them and show them what you can do with the data. And so data communication is a really important part. The next set of things are technical skills, and we have courses for all of those in the iSchool as part of your course preparation. So you will learn scripting. You will learn how to deal with, bring together data sources and manage data. You will have a number of courses in data visualization. I'm teaching one next spring, and machine learning and deep learning techniques, and big data, Hadoop and Spark, and so on. So we have courses in all of these major components. You'll certainly get that, but I think you need more. And that brings me to the last part, which is analytics tradecraft. Many of our courses, by the way, have a project component to them, where you'll be analyzing real world data. And I cannot overstress how important that is. And the reason for that is the last set of points that I'm making with you, analytics tradecraft. The ability to work with dirty data that have parts missing, there are parts that are wrongly coded, wrongly recorded, being able to work with managing errors from models. You know, some errors are more impactful than others. How can you build a model that makes fewer impactful errors and maybe more on the ones that are not impactful, right? That whole process to manage the impact. And lastly, problem solving and creativity. And so all of these last set of things really come not from just taking courses and learning, but from really doing things with data. And which is why in our curriculum, we put a particular focus on using real world data sets and courses with projects. And I would even say go beyond that. And if you have any chance of working with a client locally and we have help, we can help you, we can arrange that with you, for you, or doing as many projects and things as you can, it really will help you develop your analytics tradecraft. And with that, I'll just take a couple of quick questions and then I'll hand it over. Yes. So the question was, how do we collect data? So first of all, there's a ton of public data available. With APIs such as JSON and others, we can access data. And in fact, many of these commercial projects depend in large part on success getting data from public sources, like the marketing attribution example. The second thing is the data is really going to come from the company. A company has a problem they want to solve, and the only way they can do it is by working with data scientists to help solve that problem. So what really motivates the data sharing is the desire to solve a problem. All right. One more, yes. So the question is, are there any certifications available that one can use to certify these skills? And there are. For example, Tableau has one, and there's some other ones available for our language and others. But the biggest thing is really working, trying to find local projects, companies that you work with, and putting those stories on your resume. That's a really good way to certify the skill. So for example, the students who did the Food Link project, they had a number of things on resume. Every time they handed a resume to someone, they would just go to click on that and they would ask about that. So that's a great example of the value of these projects that you do outside that have a big impact on how people perceive your skills. Thank you, everyone.